Welcome to Spring LIB.
In this problem, we have the circuit. This is the battery, and we have a switch. This is C1, and we have C2 and the C3 connected in series. So C1, V, C2, C3. All right, and so the values for V is 12 volts. C1 is 4 microfarads. C2 is 6 microfarads. And C3 is 3 microfarads, right? Okay. So initially we turn the switch to the left-hand side. And in that case, this will become a closed loop, right? So we can simply ignore C2 and C3. So the charge stored in C1 initially is Q1 equal to V times C1 equal 48 microcoulombs. Okay. And then we just cut off this switch and move the switch to the right hand side. In that case, this will become a closed loop. And we want to find out the charge distribution, C1, C2, and C3. So suppose the charge stored in C1 is Q1, and on C2 and C3 are Q2 and the Q3. So because as you can see that the C2 is in series of C3, so Q2 will be equal to Q3. Will be equal to Q3. The combination of C2 and C3 have the total capacitance C23 equal to C2 C3 over C2 plus C3. Okay, so this gives you 2 microfarads. And we can derive the expression Q1, which is the charge stored in C1, plus Q2. So Q2 is the charge stored in C2, and Q3 is the charge stored in Q3. However, the charge stored in the combination of C2 and C3 also equal to C2, also equal to Q2. That's because on this plate, suppose on this plate, this is positive, this will be negative. This is a positive, this will be negative. So this negative plate will be crossed out with this positive plate. So we only consider this positive plate and this negative plate. Okay. So we have Q1 plus Q2 equal to the total charge, which is capital Q1 or 48 microcoulombs. And we also have the second relation, because C1 is actually in parallel with the combined capacitor. Okay. So we have let me see, Q1 over C1. So that is the voltage across the C1 equal to Q2 over C23. Okay. So as I mentioned before, Q2 is also the charge across the combined capacitor. Okay. So the combined capacitance equal to Q23. So we just use Q2 over C23 to express the voltage across the combined C2 and C3. So so the second expression also we can simplify it as Q1 equal to 2 times Q2. So we can solve for Q1 and Q2 by using these two equations, and you can see that Q1 is 32 microcoulombs, Q2 is 16 microcoulombs, and the Q2 also equal to Q3. Yes, so that's it.